Welcome back, AP Statistics. Brief video today finishing up our discussion on sampling. In our last episode, we talked about the simple random sample, wherein each subject of the population is equally likely to be sampled, and each possible combination of subjects is equally likely to be sampled. This is the gold standard for sampling. But we can go off the beaten path by doing some stratified sampling. Stratified sampling is useful when we look at our population and see that there are groups that collectively will answer similar to each other but different than other groups in the population. And each of those groups takes up a different proportion of the population, and we'd like our sample to resemble the population. So in stratified sampling, we divide the population into strata, and strata are groups that we assume will produce different results from each other, like, for example, Republicans and Democrats, children and adults, etc. And then we sample from each stratum, that's the singular of strata. So we sample from each stratum in proportion to its representation in the population. So the example I used is in a town that, say, consisted of 55% Republicans and 45% Democrats. I would want 55% of my sample to be Republicans and 45% of my sample to be Democrats. So if I were employing stratified sampling, I would do a simple random sample of Republicans, a simple random sample of Democrats, and force my sample to have a 55-45 split. In contrast with cluster sampling, in which we divide the population into clusters. Now, those are groups too, but they are groups that we assume will produce roughly the same results one to another, as opposed to strata, which we assume will produce different results from each other, right? So clusters could be like restaurants in a restaurant chain or offices of some nationwide business. And then we sample from a few clusters to learn about the population. This makes studying a large population easier. So stratified sampling, we assume the groups are different, and we sample according to their representation in the population. Cluster sampling, we assume that groups that we could divide the population into are going to be the same, roughly, and we would sample from a few of those clusters to learn about a big population. So now we're going to talk about multi-stage sampling. Multi-stage sampling is just a conglomerate of different kinds of sampling. And so multi-stage sampling is sampling that involves several different kinds of sampling. This sentence is brought to you by the word sampling. This is useful when elements of stratified sampling and cluster sampling can be employed. All right, so we're going to divide the sampling into several stages, some of which will be more stratified and some of which will be cluster in nature. So here's a scenario in which we can use multi-stage sampling. From our textbook. Having learned that freshmen are housed in separate dorms that's from a previous example we didn't look at, allowed you to sample their attitudes about campus food by going into dorms chosen at random. But you're still concerned about possible differences in opinions between men and women. It turns out that these freshman dorms house the sexes on alternate floors. So say if you were going to a dorm, maybe there's a dorm of gentlemen at the bottom, and then you have ladies a floor up, and then gentlemen, and then ladies, and so on and so forth. So how could you design a sampling plan that uses this fact to your advantage? Think about how you could use a bit of cluster sampling and a bit of stratified sampling to aid in your problem solving. Devise a plan, and then compare it with the plan that the book has. Okay, I'll assume we're ready to continue. Check out this possible plan. You can stratify your sample by sex. You want to make sure that your proportion of men and women is going to be proportional to their representation in the population. So that calls for stratifying. You wouldn't want to accidentally choose a sample that grossly misrepresented the proportion of men and women on campus. That would not produce good results. I would first choose 1 or 2 dorms at random and then select some dorm floors at random from among those that house men and separately from among those that house women. Then I could treat each floor as a cluster. All right, so now we're employing some cluster sampling. we're assuming that each floor of men is going to be roughly the same, and each floor of women is going to be roughly the same. So we can treat those groups as clusters, and then interview everyone on that floor. So we want to make sure we're sampling proportionally to the representation of men and women on campus. But once we narrow that down, we can go to the men's floors and the women's floors and assume that a floor of men here will not answer much different than a floor of men somewhere else, and same with floors of women. All right. Systematic sampling. All right, systematic sampling. Sampling in a way in which every kth, where k is some constant, subject is sampled from the population is called systematic sampling. Now, what does that look like? Well, here's what it looks like. For example, police officers could stop every kth car to check for proper use of seatbelts. And this actually happened when I was a kid. I remember driving with my family, and they were stopping every, 10th car or so to see if people were properly using seatbelts. Whether or not that was actually what they were checking for, I am not sure. However, that is their business and not mine. But that is an example of systematic sampling. In order for systematic sampling to be random as possible, the first individual chosen must be random. So we need to randomly select our first subject. Then the order of the list would not favor us choosing particular responses over others. We want to randomize this as much as possible. A grossly silly example here is if we were to, from the last example, be choosing floors and doing it in a systematic way. If we started with a men's floor and then said, okay, we're going to do every other floor, well, we would skip all the women's floors and only pick the men's floors. That's not very random, and it also doesn't do a good job representing the population. So if we're going to do a bit of systematic sampling, we want to make sure that our system does not favor selecting certain people as opposed to others and doesn't really mess up our sample and make it not represent the population. Systematic sampling is often less expensive and less laborious than true random samples. It's not nearly as random as all of the other methods that we've talked about, but it is very easy to do and decently effective. So we're going to talk about identifying the types of sampling. We have 4 examples here, letters A, B, C, and D. Feel free to take your time, consider which type of sampling we're using in each of these examples, pause the video, and we'll review these after you've unpaused the video and given your answers. All right, I'll assume we're ready to continue. So we have a sample of 300 passengers on a flight from San Fran to Tokyo. And for letter A, we are picking every 10th passenger as people board the plane, starting with a randomly chosen passenger among the first 10. That one is pretty obviously systematic sampling, all right? We pick every 10th passenger, so K equals 10 in that place. Every kth passenger is every 10th passenger. And we start with a randomly chosen passenger among the first 10, all right? So maybe we choose a random number, say that number is, 7. And we start with the 7th passenger, okay? So, letter B. From the boarding list, randomly choose 5 people flying first class and 25 of the other passengers. Now, if we make an assumption that 1 out of every 6 people flying is first class, this would be a good example of stratified sampling, all right? We would choose 5 people randomly from the 1/6 that are flying first class, and 25 randomly from those who are not flying first class. So that'd be stratifying, sampling according to the representation in the population. Okay, let's look at letter C. Randomly generate 30 seat numbers and survey the passengers who sit there. Randomly generating 30 seat numbers, no other details other than that. That is a simple random sample. Every possible combination of 30 is equally likely, and everyone is equally likely to be chosen. That is a simple random sample. And part D, randomly select a seat position, right window, right center, right aisle, etc., and survey all the passengers sitting in those seats. Now, this is a sneaky one. You may have thought systematic, but there's no indication that we are choosing every fifth passenger, or every seventh passenger, or every other row. There's no indication of that. What this example does is divide the plane into clusters. For example, right window, right center, right aisle, those are all clusters. And we're making an assumption here. We're assuming that each one of those rows is going to be roughly the same in terms of how they'd answer the survey questions as any other row. So by studying one of the rows, we can learn about all of the rows. That is a sneaky example of cluster sampling.